Hi, everyone. This is the Hungry Math Professor here, and today I'm going to be talking about a paper entitled Psychologism and Behaviorism by Ned Block. This was published in 1981 in the Philosophical Review, and I purposely am reading this after reading Computing Machinery and Intelligence by Alan Turing because this paper is critical of the Turing test in a very substantial way, and I wanted to read it afterwards as a conversation, if you will, between these two papers and these big ideas. And my plan is to read several of these sort of papers on artificial intelligence, consciousness, and what it means to be intelligent and thinking and these kinds of things. So that's where we're at. And I wanted to start by even just reading the intro paragraph here because the title is Psychologism and Behaviorism, and the entire paper is a sort of conversation between these two different views of what it means for humans and machines to be intelligent. So, in this opening paragraph, Ned writes, "Let psychologism be the doctrine that whether behavior is intelligent behavior depends on the character of the internal information processing that produces it. More specifically, I mean psychologism to involve the doctrine that two systems could have actual and potential behavior typical of familiar intelligent beings, that the two systems could be exactly alike in their actual and potential behavior, and in their behavioral dispositions and capacities and counterfactual behavioral properties. The two systems could be alike in all these ways, yet there could be a difference in the information processing that mediates their stimuli and responses that determines that one is not at all intelligent while the other is fully intelligent." So that's he starts off with a bang and explaining sort of what his position is. And the rest of the paper is going to be to try to tease apart, how to argue for that and what he's arguing against. Um, in the next paragraph, though, he claims he's going to make two claims in this paper. First, psychologism is true, and thus a natural behaviorist analysis of intelligence that is incompatible with psychologism is false. And second, the standard arguments against behaviorism are inadequate to defeat this natural behaviorist analysis of intelligence or to establish psychologism. Okay, so he tells us what psychologism is, but he doesn't tell us what behaviorism is, at least not right out the gate here. I think that's partly because he's assuming that the audience sort of has a good understanding of behaviorism, but also he's going to spend a lot of the rest of the paper explaining different ways of describing behaviorism. But let me just give you a basic understanding. The behaviorist says, listen, what it means to be intelligent is simply a set of responses to certain inputs. So it's just a certain behavior that we can describe or understand. And if someone or something can exhibit certain behavior, then that is what it means to be intelligent. And it's not about um, the mechanism used to produce that behavior, right? That intelligence is simply a function of a certain type of behavior on the output side of a machine or a human being or an animal, or fill in the blank with anything else you might want to consider. And of course, psychologism, as he'd explained in that first paragraph, is arguing that that's not the case. Now, right away, he comes up with this Martian example where he says, you can imagine like a Martian race coming to Earth, or some aliens or whatever coming to Earth, and maybe we us let's imagine that they're a friendly alien species, and somehow we are friendly towards them, and you can imagine collaborating with these aliens in art, and maybe writing books together and doing science together and mathematics together, and maybe they have a very different notation in mathematics, or um a very different approach, but like we both learn from each other. And yet, when we examine how the Martians are internally constructed, we notice that they are extremely different than us in the way that we're internally constructed, in the way that we actually think. And what he's trying to say is that psychologism argues that the internal structure is important, but it's not that what it means to be intelligent means you have to have the exact same internal structure that human beings have. And so his point is that these Martians could have a very different internal structure to how they actually produce their intelligent behavior, but yet could still be intelligent. And again, his point here is that we shouldn't be chauvinistic about humanness, and we shouldn't like too tightly define intelligence in terms of what it means to be human. Of course, part of the reason why we're asking these questions is to understand what makes humans different than machines, possibly, or what makes them possibly the same in the future. But he just wants to admit right away that, um, the point here is not to just so tightly define intelligence in terms of human internal workings, right? There could be many different alien species whose all their internal workings could be extremely different, and yet they can all be intelligent in some way. And so I like that he brings that up right in the very beginning, right? And actually, Alan Turing in his paper talks about this in a few different places, that as human beings we have this very natural response to say, no, like these computers are different. Like, no, humans are special. We make poems, we make art, we make beautiful mathematics and science, and these machines can't do that. And we get very defensive. And this defensiveness is an interesting, like, psychological phenomena to study and to understand. But we need to separate that like natural feeling and reaction that we have. We need to separate that from the question of what it means to be intelligent, right? Just because as human beings we get defensive about the idea that computers could be intelligent doesn't mean that that defensiveness has any like teeth to it, right? Has any actual force to it, right? It's again still a very interesting psychological question to understand why we feel that way. Perhaps not a very difficult question, depending on how you think about it, but it's a very different question than the more philosophical and precise, hopefully precise, question about what it means to be intelligent. Of course, part of the goal is to make it more precise. So, yeah, Turing brings that up as well. I think we all need to agree that our goal here is not just to describe humans; it's to try to understand um, intelligence more carefully. Now, at this point in the paper, he's going to review the Turing test because this is a major important part of what he's going to do in this paper, which is to criticize the Turing test. So he needs to introduce it in some way, right? So, um, first of all, the Turing test, you imagine there is one human and there is one computer, each in their own separate rooms that they can like type out responses. And then there's a human judge in another room who is getting responses from both the computer and from the human. And that judge needs to decide, which one's the human and which one's the computer. For instance, this is one way of doing that. That's how he sets it up. And right away, he's going to um, bring up some important issues with the Turing test. Um, First of all, the test is not infallible, right? It's more of a litmus test. And the main issue is that the human judge, there can be a very wide range of human judges in what their capacity may or may not be to judge, right? So, for instance, maybe you are an AI researcher, and that can very much change how well you are at being a judge of a Turing test. Or maybe you're like a very simple-minded person and you're easily fooled. Um, and if a computer can fool that very simple-minded person, it doesn't seem like that has anything to do with the computer being intelligent, or at least it's not sure, right? And there's also questions of like, as we understand these AI systems like large language models, for instance, better and better, does it become harder to convince us that they are human, or does it become easier? Like, the tests some can change over time with our human understanding of what the machines are doing, and that can affect our ability to be a good or a bad judge in this Turing test situation. So there's a lot of subjectivity in the judge element of this test. Okay, so we can understand that issue. Again, the test could still be reasonable. Maybe we like, you know, we do the test with many, many different human judges and we average over them or something like that. There's many different ways you can imagine fixing this particular issue. But it is an issue, I think, with the Turing test as far as how to define who a good judge is and who a poor judge is and how we should deal with this sort of subjectivity in the test. He also brings up this interesting example of a psychiatrist's mimicry example where people created a computer system that could was programmed to just kind of make typical psychiatrist remarks to a patient, and it was reasonably good at fooling people, at least in short periods of time. And it wasn't even that sophisticatedly programmed. So this was like a nice simple example of how, like maybe you can imagine the psychiatrist, you're telling the psychiatrist about your family, and then the computer system says something like, "Oh, elaborate more on what your dad said there," or, "How does that make you feel about your self-image?" Or I don't know. You can just imagine like these sort of couched responses, but if the human being was feeling some kind of psychological relief from this questioning, perhaps they would be more inclined to believe it's true because they want it to be true, or because it's making them feel better about themselves, or it's making them feel listened to, or something. There's so many different components of what can make somebody want to believe that they're talking to a human being. And that's a big, I think, issue with the Turing test. But um, what Ned does here is he's going to, throughout the paper twice, he's going to update the Turing test and the definition of intelligence. So first of all, the Turing test definition of intelligence could be just that a computer passes the Turing test. Maybe that's all that's required, right? And that has some issues, as we've been talking about. So the first thing he's going to do is to give a new definition of intelligence in terms of the Turing test, or like a behaviorist approach. So the first new definition he gives is that intelligence is the disposition to produce a sensible sequence of verbal responses to a sequence of verbal stimuli, whatever they may be. So he talks about how it has to have the disposition to produce a sensible sequence of verbal responses to a sequence of verbal stimuli. And this is supposed to, um, relieve us of some of the judge's issues, right? So this part of introducing the disposition is a way of avoiding the fact that the judges may not be very good at determining whether the computer has that disposition. So as Ned updates his definition of what the behaviorist defines intelligence in terms of a Turing test, he has to admit that he's going to make it less and less actionable as a test because it's hard to say what disposition, how to like measure the disposition, right? The point of the Turing test, I think, was in part was to be very practical. It's something you could actually do. Now, with this definition using disposition to produce a sensible sequence of verbal responses, it becomes less practical of a test to actually implement. But Ned is not concerned with that because his goal is to in this paper is to produce the strongest version of behaviorism he can by updating this definition and then knock that definition down, right? So his goal is to make this as strong as possible. Whether it's practically or not is not important for him because he wants to make it as strong as possible and then knock it down with a what he considers a death blow, right? So I think this is a good strategy in a philosophical paper to try to do that, to take your opponent and make the strongest version of their argument you can, maybe even stronger than they'd willing to go. And then if you can still knock down that even stronger version of their argument, then you've created a very strong argument for your position, right? So that's very good. Now, to this disposition definition, he brings up another example, which is due to Hilary Putnam. And this example is of these like perfect pain actors, right? So you can imagine, like, again, let's say some Martian species, and maybe they are experiencing pain. Let's say they're like putting their hand too close to fire or something, or they just got hit in the leg, or I don't know, like it is something that's producing pain, but yet their behavior they're able to mask that behavior so effectively that no human has any perceptible ability to determine the fact that they experience pain. And so this is supposed to be an issue, right? Because there's no measurable behavior that indicates that these um, that this species is feeling any pain, right? And so, if there's no measurable behavior, then how does the behaviorist um, classify them as having pain or not, right? It's supposed to point to the fact that pain is still somehow a something that's experienced internally and not necessarily always always given by some behavior on the outside. Um, but the thing is that pain is not really what we care about when it comes to intelligence. So what Ned points out next is that first of all, the Turing test doesn't have to be a necessary and sufficient test for intelligence. It could just be a sufficient test. And the way I read Turing's paper is I thought he was saying that it was just a sufficient test of intelligence and not a necessary and sufficient test, meaning that if a computer passes the Turing test, it doesn't mean that they're intelligent. But if a computer is intelligent, then they should pass the Turing test, right? So that's what I mean by it's sufficient, but not necessary. Okay. And he points that out. And he also points that out that, like, unlike the pain example, you could imagine a computer that could pretend to be non-intelligent, right? And maybe they can do it in a way that's just completely imperceptible to human beings. They're just completely convincing that they are not intelligent, right? And you can imagine such a computer doing such something like that, or some AI system. Um, and they could nonetheless be intelligent. But his point is that the opposite is not imaginable. You can't really imagine a computer system which is unintelligent and which can pretend to be intelligent. At least, if you define the bar of intelligence high enough. And I think he's got a point here that this only goes in one direction. And so the Turing test could still be a sufficient condition for intelligence, just not a necessary one, right? So if um, a computer or a human being or something other being does not pass the Turing test, then they may or may not be intelligent. We can't say anything about that. But if they do pass the Turing test, then they should be intelligent, right? So that's the idea. I think this is a good idea, and but it reminds me of the Goodwill Hunting bar scene. I don't know if you remember this Goodwill Hunting bar scene. Um, Matt Damon's character is at this bar, and there's this beautiful woman at the bar, and this guy, and the woman and this other guy are both like Harvard students, and this guy is trying to impress her by rattling off some history that he's learned. And the interesting part is that, and he's sort of convincing that he is somewhat intelligent, but also very smug. And then Matt Damon's character just rips him a new one and completely shows him to be a fraud, right? And anyway, my point of bringing that up is that there is levels to this. I think that a reasonably intelligent person could convince people that they are really like super intelligent, even if they aren't. But so there are degrees to this, but I think a completely unintelligent being or computer would have a almost impossible time convincing reasonable people that they are intelligent. So I think anyway, Ned has a good example here. And I think that's is a strong point. And at this point, he's going to, after some more discussion, he's going to revise the definition one more time. This will be the last time that he revises the behaviorist's definition of intelligence in terms of the Turing test. So let me read that this last definition. So intelligence is the capacity to produce a sensible sequence of verbal responses to a sequence of verbal stimuli, whatever that may be. So his point here is that if the computer, which is intelligent, can pretend to be lacking in intelligence, that doesn't matter for this new definition because this new definition says intelligence is the capacity to produce a sensible sequence of verbal responses to a sequence of verbal stimuli, whatever they may be. So it doesn't matter if it always pretends not to be intelligent. The fact that it has the capacity to produce those responses means that it is intelligent under this definition. Again, this updated definition is like not practical anymore. It's not something that we can necessarily, it's not actionable. But again, his goal is not to make things actionable here. His goal is to produce the strongest version of behaviorism that he can using the Turing test, some version of the Turing test, and then knock it down, right? So that's where he's at. And now at this point in the paper, he's going to um, bring up his main thought experiment, which he does not call the blockheads, but has now been named by other philosophers and coined the blockhead thought experiment. So that's what this is. Let me just read this paragraph that he uses to overview his goal here. So my strategy will be to describe a machine that produces a sensible sequence of verbal responses to verbal stimuli. The machine is thus intelligent according to the Neo-Turing test conception of intelligence. However, according to me, a knowledge of the machine's internal information processing shows conclusively that it is totally lacking in intelligence. Okay, so that's his goal, and that's how he's going to knock down um, behaviorism. Okay, so let me try to describe this blockhead example to you, and then we'll go through some objections and finish up this discussion here. So, how does the blockhead example work? Well, here's what you need to imagine. So, imagine that you could program a certain so let's say we're going to do the Turing test for an hour. Okay, let's just fix some amount of time. And then after that hour, the human judge is going to determine whether it's a human or a computer. And you can imagine changing this to 10 hours, days, I don't know. You can imagine changing this. It's not that important. But let's just say an hour, okay? So what we're going to do is compile this massive sort of database of trees of possible responses to inputs by the human judge. Okay, so imagine that the human judge asks a particular question, and then we're going to build a tree of possible responses, and then of those responses, the human will answer another question, and then we'll build a tree from there of possible responses. And we're going to build this ginormous data structure of possible responses to possible questions by the human judge. And there's going to be some humans involved to determine what are reasonable responses. So again, these reasonable responses are strings of words after another. And so they need to be sentences that not only like syntactically make sense, but also are sentences that humans would uh, acknowledge as reasonable, and also not just that, but acknowledge as reasonable responses. What's interesting about this is sort of what large language models do, except they don't do it in this sort of like brute force way that Ned Block is describing here. As I understand large language models, there's some sort of like probabilistic part here which saves the computer a lot of time and just tries to like probabilistically um, what I mean is like it tries to create a reasonable sentence with high probability instead of trying to like build out like entire trees of possible responses to every possible input, which is like combinatorially impossible. But just to point out, Ned Block is not concerned with whether this blockhead is like actually something that we could build. That's not his goal here, right? So anyway, so he's happy to describe a system that like, creates these massive data structures of all possible or all possible like responses to reasonable questions in an hour. Okay, this is a thought experiment. I think it's a reasonable thought experiment. So unlike large language models, which can't possibly do that, but only can like produce reasonable a certain paired off sort of tree of reasonable responses with high probabilities, these blockheads can do the impossible and or not really impossible, but they can do this like very impractical thing of building out these entirely long um, trees of possible responses. And his point is that, if you were to converse with this blockhead that had this ability to create these trees that were sort of overseen by human beings to make sure that they were reasonable trees of responses, then you would be convinced by this in an hour, probably, right? Because the computer or this blockhead has been given very reasonable responses to a lot of questions that you're going to ask, and in some sense, the humans have already vetted that these are reasonable responses. So, um, you know, you're going to also probably think that they're reasonable responses, right? So, his point is that this has the capacity to respond reasonably to um, the Turing test kind of inputs. And so it satisfies this souped up version of the Turing test definition of intelligence for the behaviorist. But yet he argues that we would not consider this blockheads to be intelligent. And I have to agree with him to some degree that I don't think I consider this blockhead to be intelligent. Of course, there's some issues about like, well, what if you could do this example not with an hour, but with like any reasonable amount of time that a human could live. Like, let's say you can do this for like, I don't know, 130 years. You can produce all possible strings of sentences that are reasonable to respond to any other sentence a human being could ask in 130 years. Now, this is insane, insane combinatorial nightmare. But let's imagine that you could do that um, then in principle, these blockheads could walk around, give them some human-looking body and act like humans all the time. And it reminds me of this sort of solipsism objection that Turing points to, which is, for all we know, all human beings are blockheads except for me. Like maybe I'm the only, intelligent, conscious human being walking around, and all the other people are just blockheads that I assume are intelligent like me and have these conscious experiences, but maybe don't. I'm kind of mixing up intelligence and consciousness here, so let me not go too far with that right now. But there is an interesting issue there. And towards the end of the paper, he's going to respond to a bunch of objections, and I don't want to go through every single objection. I'm not going through the entirety of the paper, so I'll let you read the paper for yourself. But there is one objection that I had myself, and then he raised in the paper that I do want to bring up because it was my objection that I had naturally. And the the thing is that there's this objection of like it's objection 4 and 5, by the way, in the paper, that goes roughly to the idea that like, how do we know that in some sense humans are not like the blockheads, right? I mean, I kind of just brought this up with the solipsism point. But what if human intelligence is not like the machine, like not exactly like the blockhead, but can eventually be completely described by a mathematical theory? Would you say that we are still intelligent then? Or is there something like about being able to completely describe it by some mathematical theory, meaning that it's completely predictable, that makes it not intelligent? I think Ned, to that particular objection, is going to say, no, it's not about, predictability is fine. But somehow he's going to argue that when you describe the human being via this sort of mathematical theory, that there's going to be some inner workings that we can point to and say, oh, that's intelligence, and what these blockhead is doing is not intelligence. It's interesting because the blockhead does remind me of like this idea in computer science that like you can design what we call a brute force algorithm, right? And we often will sort of dismiss it as like not really intelligent or not really an interesting way to solve a problem. Of course, if it works, it works, and so you might be able to use a brute force algorithm sometimes, but ultimately, we're looking for an algorithm that has a little bit more insight into a possible solution and has a little more of a pretty solution, right? So I think Ned's point to some degree is that if we could describe human intelligence completely as a mathematical theory, then there will be something in there that we can point to as somehow some beautiful ideas that are not just like a brute force algorithm, where his blockheads are just like a completely brute force algorithm. And I do agree with him that somehow the blockheads are just like a brute force algorithm, and that does seem to be not really what I think of as intelligence. So I give him that. But my, to continue this objection a little bit, Like, could we argue that our responses are simply written in our genes in some complex way as a function of our experiences? That, we say that like the problem with the blockhead is that they're just intelligence because the programmer who created this giant list of possible strings is intelligent. But in the case of human beings, you could argue possibly that like our genes are some really complex programming, and we are just somehow a function of our genes in some way. And so, does that make us not intelligent if we are just sort of responding to our programming in our genes? And our genes were created over, billions of years of evolution. And so, would we say that evolution is intelligent? I'm not so sure that we would, though there is a process there that we can describe, and we can point to certain work, internal workings inside of evolution that maybe we can say are intelligent. But I think we would not want to call evolution intelligent. Um, and so, if we're just responding to our genes, then my question would just be, is this really intelligence, or um, again, are we basically just trying to save humans from being classified as machines in some way, right? I don't want to go too far with this, but I just want to say that I think this paper is good in the sense that it is tightening up our intuitions for what intelligence is. I think pointing us into some kind of internal workings of humans or Martians or other beings is important to point us in the right direction. But I think it's really difficult to try to say, what those internal workings should be to be intelligent. And that's sort of the big part of what we want to do here. So, and Ned is very honest about this. He says, I didn't give a positive definition of what intelligence is. I admit that. Uh, but, um, you know, it is very difficult to do. And he also acknowledges that there can be many different ways that people can be internally internal workings could be organized that could produce intelligence. So, but anyway, his point was just to knock down the behaviorist approach to intelligence. And I think he did do that. At least he does bring up very, a lot of important objections to behaviorism. And in that sense, I think the paper is successful because I think a philosophical paper, oftentimes its goal is to do just that, is to just kind of like hone in our intuitions, to sort of criticize other positions and show why they're not sufficient or not quite working, and to just point us in a better direction for thinking. And I think he definitely did that much. And, it's now we have to continue to read other philosophers and understand the conversation that is continuing to happen in the community and sharpen up our objections, sharpen up our intuitions more and more to what it is to be intelligent. And again, I think he does point to us, at least, that there needs to be something about the internal mechanism, something about the way things are programmed that has some sort of insight that's more than just some brute force algorithm. And our question now is like, is he right about that? Right? Is when we look at human beings, do we think that it's really beautiful and more insightful just because we don't understand it yet? And when we understand exactly, if we can someday completely map out the human brain, will we not see it as like as intelligent as we used to? I don't know. I can't answer these questions, but this is the question that it brings to me. And I'm going to leave the discussion there. Please check out this paper. Let me know what you think. Let me know if you have any questions or any comments about what I said. Like, comment, and subscribe to this video and my channel. And I hope to see you at another video discussion.